once again. Welcome back. The goal for this stream and video is going to be to basically try to use Rust traits more wherever we can. So I was thinking about the stuff we've done in the previous video. So basically that thing where we were kind of wrapping some fields in order to expose getters and setters for those fields that would work as expected. And I think this could be done probably using a trait that we can implement differently. Actually, not only differently on every language, but also differently on every type, which would basically give us more flexibility in terms of how we wrap types. So sometimes we could wrap them in a way and some others in a different way if we have to. So basically, yeah, all the stuff we've done in the derive crate. So derive src lines mod. So this thing where we define for every type how to wrap a field. This is not very flexible because we basically for the same target language, we always wrap in the same way. Or I mean, in theory, we could inside of here like try to detect which type we are wrapping and do it differently. But it's much more flexible if you can use the Rust trait system. Because yeah, it's much more powerful in terms of generics. So we can implement it in a way if I don't know, like a certain type implement a certain trait, or do it differently if it doesn't. This is especially useful for Python because the way we wrap types currently only works for PyClass types. So basically um, only for types that implement PyClass from Py03, which is not great. I mean, this basically forces us to then generate some of the getters and setters manually because we can't automatically generate them because sometimes, yeah, they don't implement this trait, which is this one right here. So yeah, basically this is what we are gonna try to do. It should work in theory. I'm not really sure about the C part because we will basically change the return type for our getters and setters, and specifically we're going to return something from a trait, basically. So I'm not sure how cbindgen is going to like that. It might be that cbindgen doesn't recognize that. So I don't know, we're going to have to see and experiment a little bit, I guess. So yeah, so first of all, we're going to try to define the trait, and we're going to do that in the FFI crate, basically not in the macro crate. I think we have a common or something. Yeah, I could try to do that here. We were actually, I think this was kind of a first experiment of doing that, which I then dropped for some reason. Let me see if we are actually using it anywhere. Yeah, we're not really using it. So we're gonna basically try to. Oh yeah, so this one was meant to be specific for types that we define, but I think we could generalize it and actually remove that. Let's see. Yeah, we also don't want this. Yeah, so basically the idea was that we would implement this trait for all of our types. So basically all of the types that we define in this crate that are wrapper for other types. I don't know, I'm gonna try to keep it a bit more generic at first, and then we're gonna see what happens. And obviously we're gonna have different implementation for different language targets. So it's going to be different for Python compared to C. I think we're going to try with Python first because it's one of the, I don't know, hardest probably to do. So if it works on Python, it's probably going to work on C as well. So I'm going to take So this is where we expose a structure, and we have this part right here, which generates getters and setters. And this is defined here, I think. Yeah. So the idea is that instead of using the wrap type, which is down here, so we're not going to use this. So the type is going to be a fixed type. I think we should define actually a structure first, more than a trait. Something like I don't really like the name, but I'm gonna start with this. Yeah. So then I can change this. So I think we actually have two basically generic types for this trait. So we have one which is what do we store, and we have another one which is what do we return from a getter, and probably also what we wanna receive from setter. I don't know if those two are the same one or if we should then separate them again. The idea is that we can only wrap stuff that implement this trait, and what we store is the store type. So that's ts store. And then we can implement some methods on this. Like, well, we could also probably implement the some traits from the standard library, like the ref, get, set. So we're probably going to do that later as well. But mainly I want to have something basically for the getter. So something that we can call from inside the getter. Get. Yeah, makes sense. And we're going to return again another type that we define in the I think we can also, no, I think I'm just gonna keep it this way. It's probably less ambiguous. I think I could change this to become like this. I'm not sure. I'm pretty sure this is more unambiguous, so we're gonna keep it this way. Okay, so something like that. And then the idea is that we can like implement this trait. So we're gonna do on Python, but we can basically implement this for every type that is a PyClass. So it's pyo3 class. And the type that we store is let's see, is a pyo3 of pi of t, and the type that we return from the getter is, let's see, oh, again, the same one. Yeah, makes sense because we just clone that type. How was that? Yeah, clone ref. So self clone ref. Oh, okay. So this is the first. Yeah. So we need a way to get this, which is like the Python context. I think we can use basically the same approach as we use in the mapping stuff, which is like using the acquire GIL, I don't know that's pronounced, function. I mean, this should work. The only thing that kind of scares me from this one is potentially deadlocks, but there was a line saying that it shouldn't deadlock, probably in here. Yeah, so in theory it shouldn't deadlock, so we can try. We're gonna remove it later. Actually, more than acquire GIL, I think I'm gonna use the with. There was something like with GIL. Yeah, I think this one. Yeah. So bucket 3 Python. Just gonna copy paste this. It's quicker. Also, with this we can actually even handle errors much more nicely. So we can change this and make this become a pi result. What is this defined? It's in the root. So we can make this become a pi result of pi. So basically, I mean, I don't really know when the cloning of reference could return an error, but I don't know. It doesn't really cost us anything more to return an error, so we're just gonna do that for, I don't know, for safety, I guess. So just gonna do okay. Oh yeah, maybe self clone ref doesn't even return an error. Let me see. Okay, no, it doesn't return an error, so it doesn't make sense to do it because. So maybe the only time when it can return an error is when we create. So I think in the new, what was that? So yeah, so this one, yeah. So the new can return a result, but yeah, that's a separate thing, so we're not gonna do that. So we're just gonna return pi of t. So yeah, in theory this should kind of work. Let's see if it compiles at least. Okay. Yeah, that makes sense. Okay, so this is, yeah, so this should be self.0, I guess. But we're gonna implement the derived trait. Yeah, so I think we can implement the derived trait and it should like automatically understand that you can use it here. Okay, so this is still Why does it say that? Oh, okay, so I guess this is because we are using like the same name, I guess. I don't know, let's try renaming this one. Oh no. So self.0. I think actually, first of all, we can remove this now that we have deref. So self. Oh yeah, no, this is wrong. Yeah, so this should be more like it, I think. But yeah, I think this is right because it says yeah, because we are storing the store type, and the get method is not implemented on the store type, is implemented on t basically. So maybe we can just simplify that a little bit and just store the t type directly. Yeah, but that's not. Okay, let's try this way. It's gonna simplify things a little bit. So this is t again. Now the only difference is that I'm gonna implement this for pio3 pi of t. Okay, so this kind of works. Yeah, so this is complaining because they have the same name. Oh, actually, I don't even need to do that because if I implement dref, you can basically call the get method from the trait itself. So yeah, I don't need to do that, I think. Okay, so it's not using this. Where? I don't know. Yeah, I don't care. I mean, just unuse the import, so those are gonna stay here for the moment. So, okay, so I can change this instead of doing that. The getter I generate. Yeah, so this is where I think the C part could break. Because here I'm gonna change the getter that I generate to return, yeah, basically that thing right here. So the getter type. Yeah, so yeah, so something like that. So the idea is that the type we add, yeah, so basically the field type, which is not, I mean, not old anymore because we're not really changing it. So the field type as wrapped struct, it should be wrapped struct field, I guess. So yeah, I'm gonna comment out. Okay, so it's already commented out. So here we have, those are getters and setters that define manually, and in theory, once this whole thing is done, I can automatically generate those as well. Because the idea that for like simple types like those, we don't need to wrap them, and the getters and setters we were generating before, they were always wrapping the type. So basically we were using this syntax only when we were exposing types that could be wrapped, and then we were generating manually, or like writing manually getters and setters for all the other types. But in theory now with this trade thing, I can decide which types, which types need to be wrapped, which don't. So yeah, so in theory, I'm gonna be able to remove those later on. But what I'm interested in, what I'm interested into right now is this thing right here. So this should generate getters and setter, and we should see this like different type. And I should also, so this is another point that I'm not really sure this can be done. So basically, I'm changing the type of our field um, to, oh no, actually, that should be fine. Do I actually need to, I don't think I need this at all, probably, because I can just, I can just store like my type t. Oh, but then, then I still need to somehow write type. So, oh, okay, no, that's fine, because I don't have a different type. Like, I always change the field type to getter, setter, wrapper of something, no matter what the type inside is, I think. So yeah, let's see if this works. I'm probably gonna have to import it. So something like that. Let's see what this expands to. I think I saw an error here somewhere. Okay, that makes sense. Not. And this 36. This is probably somewhere inside the macro. So I don't know. I'm gonna check that later. So our getter, so this gets. First of all, let's see if we wrap the type correctly. Which is so where is the definition for this? Okay, so we wrap the type like this, which is fine. And then okay, so we're gonna have to change. We're gonna basically implement the mapping stuff for that type because now this is not really implemented, so we don't have map from a reference to that. But we're gonna change it in a second. That's gonna be pretty easy to do. And then our getter, returns this type. And we don't need to do this inside. So this is gonna be like, we're gonna use the get, I think, from here. Yeah. So just like that. Oh, and this is where it was complaining about pi not existing. It's fine. So yeah, let's cargo check this. Okay, that's a good point, I think. Even though this is probably a pi class, so it should be implemented, I think. Yeah, because I was like successfully storing it inside of a pi thing. And you can only do that if it's a pi class. So yeah, it should. Oh no, okay, that's the problem. So because we're only implementing it for pi o 3 pi, But if we change this, okay, so this is why we had the store type, but then was, yeah, creating some issues, I think. Okay, so maybe we can do this. The store type, so we could say that the store type must be like, you must have a way to create it from something else. So actually not something else, from T. So you implement this trait on T, and the store type should be, we should have the map from implemented for the store type on T, which would basically allows us to just, yeah, take our T and convert it to the store type and storing that. But we still have, yeah, this issue here, because I don't know, let's try this way. So the store type must implement map from T, oh sorry, not map from self. And here we change this back. Store we change this as well. Okay, we're also going to implement the mapping thing for this, which is down here. So I think we should add an extra constraint here. Oh no, I think we can probably do it another way. So new, which takes self, I guess. And we return the getter. So we basically wrap it. So maybe that's what it's wrap. So yeah, something like that. Okay, so this should, yeah, so if you have our type T, we can wrap it, and here we convert it to the store type, and we can do that because we say that it must implement map from self. And here, instead of this, we should implement, oh no, okay, so yeah, get a set of wrapper of T, yeah, this should be fine. And we can just use the wrap type probably. Let's actually change this to this. Right? Yeah, so t.wrap. Yeah, we should also add the other constraint that t is a wrapped struct build. Okay, so yeah, we need size here. Okay, I think, yeah, I think I'm gonna have to use the trait. Oh, okay, and here we probably need more type constraints, like we had to add here. Okay, so one thing at a time. So here, okay, this should fix this, I think. Okay, I don't understand this one. So I don't understand where this is coming from. So this said expected struct found struct bio3pi in. Okay, I'm gonna try to fix this one first because I have more or less an idea of what this is. Yeah, so basically if I wanna use map from this is map from pi, yeah. So I'm gonna have to add basically those two lines here, I think. I'm just gonna use the prelude stuff for convenience. I'm gonna. So this is gonna be obviously only compiled when targeting Python, but yeah, for now that should be fine. Okay, so we still, oh yeah, so we need a lot more imports. So this is kind of bothering me. I don't understand where this is coming from. Am I maybe explicitly like casting to that type in the constructor maybe? So I'm not really doing that. So I'm just saying map from temp inner, which is, yeah, inner. and the type I'm expecting is, where is it? Is a getter setter wrapper. So is this where it was? So yeah, expect the struct found struct bio3pi in. Am I doing something weird here? So if T is a wrapped struct field, I implement map from T for that, which makes sense to me, I think. Is it like getting confused with this one? But I still need this one for the like inner store type. Because I use, yeah, map from for the kind of like inner type to create this one. Maybe I don't need to do this right here. I'll probably do this outside, so it's a bit more generic. So and I'm also gonna do something like this, so I don't have to type it every time. Okay, so if T, okay, and then T as wrap struct field store, and this is map from T, and then I can get set wrapper map from T. This should probably be public, otherwise I can create it from there. I don't know, let's see what happens. So we still have this problem here. And I don't think the ref is working. So let's be explicit here. Oh, why is that no field? Oh, okay, wait a second. So I should implement this on yeah, so this should be the like wrapper, the wrapper type, I think. But yeah, this is kind of a like, yeah, so either I implement the trait on the base type or I implement it on the wrapped type. I can do both, so I'm getting kind of confused here, I think. Let's see. Yeah, so get shouldn't take self-reference. I should take a reference to the store type, I think. Yeah, and this is why I'm probably gonna need to then implement the get method on, so basically what I was doing before. But yeah, so one thing at a time. So this is gonna be something like this. I'm gonna call it drop get, and then T. And here is where I can do self. No, actually, okay. So this is not. Yeah, because I can't really do that. So basically, I need to. Yeah, I don't really need the ref trade. Yeah. Anyway, so this is wrap struct field wrap get self.0, something like that. This should call basically this. So this is gonna change as well. Okay, this makes sense. Function get is private. Okay, that's easy. So I think here I can probably do this because no, this is t wrap get. Okay, so this is not okay, and I still have this issue which I don't really get where this is coming from. So let me check the expand again. Oh, maybe yeah, maybe this is the setter, I think. Can we try not generating it because I haven't done that part yet. Okay, so that was the setter. Okay, so this should be fine, I think. Let me see if we can simplify this a little bit, maybe. But yeah, the reason why this is much more flexible than basically the fixed wrapping is that I can define like for native types like U32 integer types, the store type is going to be the same. Actually, I think I could make that the default even, so I don't have to like be explicit about it. I don't know if this works, but I think it might. And we can also have like a default get implementation. Yeah, we can have a default implementation, but only if the type is clone, because we can just clone. So we're gonna maybe do that later. And we don't need this really anymore. Yeah, I think we can just, we can implement it again later on if we need it, but I don't know. Basically, due to the way we use it, it's, yeah, probably not going to be super useful. So now we have errors. Oh, okay, so you can, oh, okay, so this is not, yeah, not stable yet, so we can't really use it. It would be cool, but all right. Okay. So this should be, yeah, should be fine, I think. I think we're gonna have to split this up into two separate types for the getters and setters. Yeah, I don't know, let's try this way. So the setter is down here. I'm gonna basically take his gonna be field tie as create common abstract field. But this time I'm gonna take the setter type. And I think we're gonna have to remove this result thing, at least for now. Maybe later on we can add it back. But... So I don't think we can implement this then, because if we can't have, I don't know, I'm gonna leave it there, but if we can't have default type, I don't know, associated types, I think they're called. I don't know. Yeah, I don't know if we can do that. So up set. Okay, so yeah, so this is a little bit different because we should like mutate ourselves. Oh no, I don't think we should. Yeah, we can just return a new self store, I think, and we're just gonna basically replace it then. I don't know. Let's try this way. So what do we do in the setter? Just create a new pie. Okay. So yeah, I think for that we can use the map from again. So wait, the idea is that yeah, so here we're gonna have the set and value, which is t as abstract field, and we're gonna change the inside, so self.0 equal t set value, I think. And in this case, yeah, we can probably just do not from s. We should, yeah, start creating it once again. Still have errors. Oh yeah, should import this. Okay, so this should be again public. Oh, it was public. It was just wasn't a function, I guess. So this is one thing. And then where do you use pi that you don't like? Maybe in here. Yeah, because I removed it, but I didn't change how we do this. There's already a thing to do to handle errors. At least we're gonna add it in here because this is where we ignore the error. Actually, I mean, I think it's even fine because I think Pio3 basically wraps every Rust call. Um, they basically catch any panic and they turn that into a Python exception. So, I mean, it's probably not ideal, but I don't think this would make the entire like program crash, I think. Yeah, I don't know. Just gonna leave it like that for now. So what do we do here? This is set field ident, I think, and we can remove this. Let's try. Okay, so this compiles. Okay, yeah, I think we can try running it for Python, see if that works. Then we're gonna try with C because I'm afraid basically C binding is not gonna recognize those and I think it's just gonna like maybe skip exposing the method entirely because it doesn't understand what's the return type. So if this doesn't work, yeah, I don't think we can do that much about it. We're just gonna have to go back to the previous approach. Yeah, I don't know. I think if this works, it should be a bit like more flexible, I think. Otherwise, we would have to like match types in here, and based on the type, we would change the way we wrap it. But yeah, I don't know. I think it can become a bit of a mess because then, like in the getter and setter, we were. Oh, I should also use. Why did I complain that I'm not using the trait here? Or maybe I can remove this one then. I don't know, but yeah, the problem is that like in the setter, we were basically assuming that this was a PyClass like type. We were creating like this a new object and everything. And if we have like different wrapping for different types, we can't really assume that, I think. So yeah. I think somebody joined on Discord or something. Oh, hi Ricardo.
Hi.
I was just like explaining. I'm trying to basically use traits a little bit more instead of mapping types manually. So what I was doing until basically before this video, I was basically matching types by hand and deciding like if I see this type, I'm gonna wrap it in this way, and if it's a different type, I'm gonna wrap it in a different way. And now instead, I'm just trying to use traits where I can implement a trait differently and based on the like inner types. So this is where I define how to like kind of wrap a type, which I think is a bit more flexible than doing it manually and having to uh, match types manually because you can use generics and everything. So I'm just kind of doing a bit of refactoring. Um, yeah, I don't know. I mean, I'm not sure if this is gonna work. I think it should work on Python. I'm not sure if this is gonna work with C because we change our methods to return those like weird types. And I think cbindgen, which is the tool that we use to generate the headers, it might not like recognize what this is. So I don't know. We're gonna have to try that because if it doesn't work, we have to go back to the previous method. Yeah, which is not probably as flexible, but I don't know. Just gonna try with that and see what happens. If you have any questions or anything, feel free to interrupt me and ask them. I don't know. I think it might be useful for people who watch these videos later if there's something that is not super clear. Uh, yeah, go ahead and ask. Okay. So yeah, I think I'm gonna try this. So I'm done implementing it for Python, or at least like a first kind of prototype. Um, I'm gonna try if that works, and then I'm gonna go try that on C as well. So this is okay. So this was the example that I was using before. That was already basically testing those stuff. So trying to set like a field, or I think it's called a property in Python, in a nested like kind of object. So just gonna use this example again and see if that works. Okay, so yeah, I think this worked because the idea is that we create like an inner type uh, of value 10, just kind of an arbitrary thing. Then we create an outer type that contains the inner type, and then we try to change directly the val property of inner through outer. So we go o.inner.val, and in this case we try to multiply that by 5, and it works. So yeah, this is nice. And then we also try to completely replace the inner type. So we just replace it with a new inner, which has a different value. And again, this works. So, okay, so this is fine for Python. I think I could try to commit this. Oh, no, I think I'm going to do C first. Yeah, because if it doesn't work, I'm just going to roll back everything. So I'm going to try with C very quickly. So all of this, which is Python specific, I'm going to move that into a module and only compile that module on Python. So see it. Okay. Can probably clean this up a little bit. Okay. So this is only under Python, and then we have the C1. Do it here. Oh, first let's check that this still works. And it doesn't work anymore. So, oh, okay. So I think I need a super. Okay, so this is still working. Then so basically I have this. So I'm gonna make like one step back. I've already explained the stuff in the previous video, but I'm just gonna like recap that a little bit. So the idea is that if we have a like a type like this one, and we want to generate the getters and setters, and this is the syntax to do that. So you can say, you can also say just the getter, just the setter, or both of them. The idea is that I want to generate the getter for this. But in this particular case, this is like kind of a, let's say, complex type. Like I normally call them nested types because this is not like an integer type, which is a simple type. This is basically a class, let's say. So yeah, one example of a complex type is a class. So this is something that can contain other stuff. Like in this case, in this example, it contains this val property. And the idea is that we don't want to clone this in the getter because then the thing we return is completely detached from the original one. So basically, if in our getter we were to clone the inner type, doing this wouldn't change anything, or at least it wouldn't change it inside O, because it will O.inner would be basically expanded to like O.getInner, but this would return a copy. So then I would change the val property of the copy. I would not change the val property of the inner inside O. So we basically have to return something that is somehow connected to the original object. But to do that, we have like different ways to do that in different languages. So for instance, in Python, we can wrap everything that is a Py class into a Py object, which basically represents any kind of Python object. And then we can clone a reference to that object. So if we do this, we get back another, basically the same type, so another Py of t. But this thing we get back is linked to the same one that, like in this case, is inside of outer. So the idea is that when we want to generate getters and setter, first of all, we have to potentially wrap the type. So we have to change. We're not going to store just the inner. In Python, we're going to store a Py of inner. And then we need to do something, let's say something special in the getter and also in the setter to return like a linked version of it. So what we do here is we have like one trait that we use to define how basically what's the type that we use to wrap our field, and also what are the types that the getter returns and what's the type that the setter wants. So like in this example, and then we have this structure which brings everything together. So the idea is that we define this trait, we define what's the type that we actually store in our structure, basically, uh, what the getter returns and what the setter wants, and then we have a method to get the value from the store, or actually from a reference to the store. We get out the getter type, and we have a way from a setter to basically create a new store. So when we want to replace a value, we take whatever type the setter wants and we completely replace the store. And then we, under Python, if for every type T that is a Py class, because we can only wrap Py classes in here. So you can see it in the new. Yeah, basically the new is only valid if T is a Py class. And also if there are these other extra constraints, which we have here. So basically for every type that satisfies those constraints, our store type is going to be pi of t. I think we can probably remove this now. Our getter will return again a pi of t because we're going to use clone ref here, which returns a pi of t again. And our setter will take just t, and we are gonna wrap, we're basically gonna call the constructor, which is here, and we're gonna take our value, which is of whatever type t, and get back a pi of t. And this is where we define how to get it. We have to acquire the lock, and in order to set it, we use the mapping functions, which is basically, in the end, still takes the lock and create a new object with the lock. But this is very flexible because for other types, like for instance, for a U32, this would be much more, like much simpler. We would just store again the same type T, like a U32. The getter would be again the same type because we don't really care. If we clone a U32, it doesn't matter because the problem is when we return something that has properties inside and somebody maybe changes those properties inside, but for a U32 we don't have properties inside, so it's fine. Or even like a string or all those type, that they would probably be fine to be returned like that. So yeah, we can basically define that based on the type. So for more complex type, we have a more complex way of returning them. And for simpler types, it's much simpler. Yeah, and now I'm gonna have to do this for C as well. So I will change. I will change the way we generate the constructor and destructor. And actually, I think so. Until this point, they were different for different languages, because the idea was, like in Python, maybe I have to do something specific, and in C I don't. But now that we use the traits, all the language specific stuff are basically inside the traits, I think. So we could probably, in this case, I'm just gonna copy paste them. But I think at some point we can just basically have just one implementation for every language, and it should work, I think. Oh no, we do have little differences. Like in C, we only generate them if the type is not opaque. But I mean, if 99% of the code is the same, we can just maybe just like encode the differences and have a method that is like generate like that returns a boolean. So like a question, should I generate this getter? And then it's just yes or no, and then the code that generates is the same, I guess. I don't know, but yeah, I'm just gonna copy paste the code first, and then we'll see. So in C, it's actually a little bit easier because we have access to basically row pointers. So we just we store a pointer to our type, and we just return, like clone the pointer whenever we want to return like a complex object. Which, I mean, if we return the same pointer, it's gonna point to the same object in memory. So if you then change the data pointed by that pointer, you're also changing the stuff inside the like containing structure. So this is the other. And also, this is very important. Should not forget about it. In the setter, we take like a new pointer, and we replace the pointer we already have with a new one. But it's very important to remember to free the old one before we replace it. Otherwise, we leak memory because we just replace a pointer with another one, but we don't free the memory that was being pointed before. So I should copy those somewhere just so I don't forget. Yeah, the getter is pretty easy, so I'm not gonna bother with that. Okay, so then I just need to, I think, implement our trait and everything in C as well. So in this case, I think I can make it a bit more generic, maybe. I would like to implement it. Maybe I can start with every T, I don't know, and then we can reduce it to every T that implements something, maybe. I don't know. No, I'm not gonna copy paste it. So basically, we store a reference. The getter returns a reference. We could actually even store a box, I think. The problem is that I think into row consumes the box, so I don't know. Yeah, so we can't like very easily get a pointer. So this would be, if we manage to store a box, it's a bit easier because the basically Rust is gonna free the memory for ourselves. So if we store a pointer, we have to do it manually. But if we store a box when we drop either the box or the all containing type, it will automatically free the memory. So this is a bit easier if we can do that. But I don't know if we can somehow get a pointer but keep like the box intact. Oh no, but well, that's the problem. If we keep the box intact and we just like somehow clone the pointer but keep the box intact, there's a problem that if you drop the object, the memory gets freed, and you have a pointer to free memory. But I don't think we can really get away with it. So in C, it's always going to be probably, even if we only store the reference, still we have like a custom destructor that frees the pointer. So yeah, that's a problem, but it's not really something that you can fix or anything. So we just have to live with it. I know there's like a pointer of no. Okay, so we can do this, and this shouldn't. Oh, okay. Yeah, this is basically what we want. So well, we can take a pointer into the box without taking like ownership of the box, I think. Yeah, this is the one that consumes the box. Uh, but yeah, this is better for us. Obviously, yeah, you have to be careful not to use the pointer after the box is destroyed, but yeah, that should be fine, I think. So, okay, so I think we can change the store type to a box of t. The getter type is a mutable reference to t, and the setter is just t, because we're gonna replace. There's still a little bit of like debate on what to do in the setter. So the options are either we take a pointer and we just take that pointer and write it inside our structure, which means that I don't know, like if you have a structure somewhere in memory and you pass a pointer to the structure to a setter, and then you change the structure, since the pointer is the same, you're also gonna change like the value inside of our type, which I don't really like. And also the lifetime issues or issue of you free the memory of that structure, but you given a pointer of that to the structure to another type, and then that other type as a pointer to memory that has already been freed. So in general, I prefer to basically clone, even if I take a reference, to clone the data. So I have like a separate instance of them. But then I don't know. The point is, maybe somebody would expect that if I give you a pointer, that then you store that pointer, and if you change the data pointed by that pointer, you expect the containing structure to also change. I don't know. So there's still a little bit of, I don't know, like debate on that, I think. But for now, I'm just gonna take t. That should be a bit easier. And then I need the wrap get and wrap set. So yeah, so if I have a reference to the store, I can basically do this, I think. Okay, so that's the constness. I don't know how to do that, how to say that. Yeah, maybe it's better if we, no, okay, so we should return a mutable pointer, because in the getter, we also return, like if we want somebody to be able to modify the inner like type. So maybe this should become a mutable reference, which is a bit more, uh, yeah, it's actually what we get. So in a getter, we get a mutable reference to our object. In Python, this is kind of hidden because it's a reference counted thing, so you don't really need a mutable reference. But in the end, yeah, it's better to just make it mutable, I think. Okay, so this is one, and the other one is just box. Okay, so I don't really know where this is coming from. Am I still, maybe I'm still wrapping the type. Oh, yeah, so this is wrong. So this should become the wrapper type or whatever. So where did I do this? yeah, so I think in Python, in Python I've done it here. So this is also like a function that we can just merge because it's going to be the same on both languages. And maybe I should make this transparent, I think. I don't know, just gonna try with this. Sorry, not transparent, like wrapper C, so that it has like a fixed layout that you can expose to see directly. I don't know. But yeah, so now we have the right inner type and the getter and setter should be right, I think. Yeah, so set inner and get. Okay, so now we have to see if cbindgen is like recognizing them or not. Yeah, so we get a getter here, which is not the right type. Yeah, I don't know if we can do something about this. Yeah, I don't think we can really do anything about it because the point is it doesn't understand like what I would like him for him to do is to go and find. Yeah, I mean it's pretty complicated to do that. It would need to understand that this is I don't know, like a box of inner in this case, and it would need to understand that this is the implementation and the getter type is a mutable reference to T. But it doesn't really, I mean, it can't really do that automatically, looks like. Did somebody join? Oh, hi, Steve.
Oh, hey, guys.
Hi.
Track of time, just joining now, but just gonna catch up wherever you're at.
Yeah, so I was like refactoring some things a little bit, but I don't think I can do that. I mean, it works, but cbindgen, which is like the tool that we use to generate the header file, doesn't, I don't know, like understand what I'm doing basically. So the point is that I changed the getters and setters to return like this thing. So basically my type now implements this trait, and this is where I define like what to take for a setter of this type. But cbindgen doesn't like understand how to resolve this. So the only thing you get in the header is just a getter or a setter here.
Oh, so it's just like getting one of the traits, something like that.
Yeah, you should basically understand like this is the trait
combination,
and which like for this type which getter and setter to use, which are for this type specifically the getter is just a mutable pointer and the setter is the type itself. But yeah, he doesn't really understand that, it looks like. So
okay.
Yeah, I don't think this is gonna work.
Back to the drawing board.
Yeah.
Well, that's what experimentation's about. Trying all the tools. By the way, thanks for getting that 5.1 out so quick. I think that'll.
Yeah, no problem. It wasn't very hard. I don't know if you've seen that. I spent a lot of time today debugging a WASM bindgen issue. Um,
Oh no,
there
I
was
didn't see that.
uh, basically our CI like started failing kind of randomly. Where was it?
Oh, okay.
Yeah, so those basically like this one. Yeah, they were failing. Oh, okay, so I can't. Oh, wait, I'm gonna try from here. Yeah, I don't really like this thing that if you're not logged in, it won't show you the logs. But yeah,
Oh, yeah, I never noticed that, I guess. Let's see. Huh.
so yeah, it was failing with those like weird errors inside of JSCs.
Hmm.
And basically in the end, it was like they did a change into scene, it's called, which is like the crate that I also use to parse
Hmm.
procedural macro stuff. And basically it was like there was kind of a bug in there. Maybe I can show you the.
Yeah. So was this another like dependency sort of thing?
Yeah, because we use I don't know exactly. I think we directly depend on JSCs, which is
Oh,
like a way to like have access to JavaScript stuff from Rust. Like you have access to all the JavaScript date object
I
and things
see.
like that. Um,
Yeah,
so yeah,
there's
I mean,
all the JavaScript types in Rust.
yeah, exactly. So this is just to say the hardest part of the release was actually debugging this. Uh, yeah,
So you're saying this was also breaking the build sporadically? That's weird that it would be sporadic though.
no,
That's
I
the
mean
worst.
this was pretty consistent, and it was just that
Okay.
it was on the new scene version, which they released, I think, like one day ago, not really that long ago. So the
Great.
previous runs of that they were working, and then they like I was about to release it, and I did the last push, and it started breaking.
Oh my gosh.
But yeah, I don't know. There's like a full explanation here. There were a ton of people like affected by this. Uh,
Okay. Yeah.
and yeah, so it took me quite a while to do that. That was the hardest part of the release in the end. And it wasn't
If
even
you,
like our bug; it was somebody else's bug. But
right. It was just a transient dependency sort of thing.
yeah,
Did I guess maybe I didn't notice that. Was that in your release notes too, or?
no, because I mean we didn't really have to change anything from our side.
Yeah.
I did a PR to this was bindgen thing. No, that's not this one. Yeah, so it's basically they were not correctly like consuming tokens. It's kind of a weird thing, but when you
From a macro thing.
yeah when you have like a custom parser, it's your responsibility to consume the tokens that you use. So in this case they
Mhm.
were parsing from this input, but the way they were doing it before, they were not consuming the thing they parsed from the basically the buffer. And so the basically the error was expected a comma here because they were not consuming this token. So the basically scene was expecting a comma here, but instead, if they had correctly consumed this token, the comma was right afterwards. So yeah, basically the problem was they were not they were parsing this. They were like understanding what this was, but they were not removing it from the like buffer of tokens. And so then
Yeah. Yeah.
the scene was expecting a comma here. Yeah. So
Yeah.
yeah,
Okay.
just want to say that that took me a long time, but we didn't really have to change anything on our side. I just did this PR and then they released it uh, like immediately. They
Oh,
did
I see.
this new one. Uh,
I see. So they fixed it so you didn't have to. I mean, you didn't have to pin some old version because they fixed a new. They released something new.
yeah, I didn't want to do that. So I mean, the plan was if they don't fix it quickly, and we're just gonna pin that. But there were
Yeah.
like a few
Yeah.
people affected, so they just I think as soon as they woke up, probably they just merged it and everything was
Okay.
yeah.
Oh, that's good. Wow. Yeah, there seems to have been a lot of that going around lately. I don't know. Everyone's pushing versions. I actually was thinking about this for the problem with hyper, and I'm thinking one of the things I noticed was they don't actually mention a minimum value, like a minimum less value.
Yeah, because I
So
think
maybe
uh,
they just always they just basically test against, in their, at least what I could tell from their pipeline, they only test against stable. So that's why they
okay.
wouldn't have got this.
Yeah, yeah, because it was
So
in the like socket too. So it's not hyper itself, it was a dependency of hyper, right?
right,
The change,
yeah,
yeah.
right. But basically, hyper depends on 014, and then SOX 2 made a breaking change in an 014.
Yeah.
Like an 014 dot something. So, or maybe it was the other way around. Yeah, because hyper depended on, yeah, I think hyper switched to 14, and then
Okay.
the older version of hyper was based on a dot 13, something like that.
Okay.
So I had to just basically get it before they upgraded to the 4, because the old 14s worked, like 14.2 or something, or 14
Yeah,
dot, one of the early 14s worked.
I think this could be considered a bug from the like hyper side, because the idea is that if you if you only do a patch level release, it should not be a
Yeah,
breaking change. So if
yeah,
maybe they just didn't notice, I don't know. If they upgraded socket 2 in a way that was breaking something, like increasing the MSRV, they should have made a non-patch release. Like
yeah.
they should have increased the minor value.
Yeah, I was actually thinking about today. I'll probably just submit them an issue,
Yeah, I
just at
mean,
least let them know. I don't have to fix it, but I'll let them know that it's breaking
yeah.
with one of the with 1.45. And,
Yeah, I mean, eventually we're gonna have to raise. I mean, it's not really a big problem for me to raise the MSRV for our project, because I mean, eventually we're gonna have to do it. But I don't like that they
yeah,
push those changes as minor,
yeah, yeah,
as patch releases.
yeah. It's bad form
Yeah,
for all the downstream projects like ours. But yeah, I guess that's I was thinking about it. And I was thinking, that's why we're a well-maintained project, because we're going to catch those things and we're going to fix them right away.
yeah, yeah. Sometimes I
So
think I'm probably a bit too, I don't know, too cautious in a way. So like, I mean, probably not really, like not even 10 people are using BDK right now, and we still, it takes a lot of time to do the releases this way. So like to be super careful, but I think it's a good, like, I mean, just a
yeah,
good practice for when BDK is going to be bigger and more people are going to be
yeah.
using it.
Yeah, I agree. It's good practice, but it's also good, in a way, it's good publicity, because we're showing we can
Yeah.
keep our project stable. So it's, anybody who wants to adopt us, they see us doing this. I think it's good advertising for our seriousness is always
No,
important.
yeah. I really care about
So
that. So, I mean, I want to be
yeah,
very precise,
yep.
because
And
I
I think
hate it
for
when people are not in their project.
yeah,
So I don't want to be like
yeah,
that.
and especially for Bitcoin projects, this is not just a game. It's real money on the line. So it's
Yeah.
good to be serious.
Yeah. So I think I'm going to have to throw away all of this because it doesn't work. So it works very well on Python, but it doesn't
Uh,
in C, because C
okay.
bindgen doesn't work. So it's kind of a C
Okay.
specific issue, but it doesn't work. So
Yeah. Well, I guess it's because C doesn't really C doesn't have any concept of traits. So something in that translation, I guess.
yeah, I
Just
mean, I
in
think
that.
in this case, I'm not really doing anything weird. Like in this case, it's just a matter of resolving a type. So I'm not like returning a trait. I'm
Oh.
just, so I'm returning like I think they're called associated types from a trait, but this is like a
Mm,
real type. So the point is, what cbingen should do is like, I'm saying inner as this trait, so it should
mm,
go look at the implementation of this trait for inner, and then see what
mm,
the setter type is. And if you do this, it's not
mm.
it's like a C safe type.
Yeah. So it should be like a normal type, basically, like
Yeah,
a
it's just T, so it's just
yeah.
itself. So this would
Mm,
basically at the end it would become inner. But
mm,
cbingen is not like smart enough to do that. So it doesn't really like understand all of this. Which it makes sense because it's probably kind of a pain to understand. With generics and everything, it's very hard to find the right implementation of this trait for this. So it makes sense that they don't do it. But in theory, this
Yeah.
is just kind of a limitation of the tool that doesn't understand this.
So what's the alternative then? Is just to not use a macro, like just to, I don't know, create an
No,
actual interface, or like create a, I don't
basically
know.
the alternative to switch back to the thing I built in the last video. So here I was trying to, like, I don't know if you remember, there were like there was a method, this one, to wrap the field, things like that. So the idea was to, instead of manually doing it, like instead of doing if type is this, wrap it this way, and if type is this other thing, wrap it the other way. The idea was just to
Okay.
use Rust traits to do that. So I would always wrap it in the same way, and then I implement the trait differently. So for different type, I can do different stuff. So it's the same concept implemented in a more like rusty way. Um, and basically, it would be just easier for me to do it because a lot of the complexity of what should I do with this type versus this other type, the compiler would handle that for me. So it would have been
So
just
now you're
easier
gonna have
for
to
me.
kind of, there's gonna be a little more manual coding this way because you're gonna have to tell it explicitly.
Yeah, I have to do it manually. Like I have to check for this
Yeah.
type and see if this type I can wrap it this way,
Yeah.
or this other type I have to wrap it the other way, and it's kind of a mess.
Yeah. Okay. Yeah. Well, I guess at some point maybe we could make a feature request over on that
Yeah, that would be
other
nice.
tool.
So I was looking at the docs very quickly because maybe they have something. I don't know. I was just maybe looking for something that they say there's a way to do that, but I don't know.
Yeah.
Not
Well, the
super
C bind
optimistic.
gen, this was part of the, wasn't this part of the Mozilla project or something? Was that what this came from?
I don't know if it's
No,
part, but
that's
I'm
something
pretty
else.
sure they use it. Like I think they use it
Maybe
for
that's where I saw it. Yeah,
yeah,
I think that's where I saw it. It's in their example. They
yeah,
were using it.
yeah.
Yeah. Okay. I see. So
I
you were
think
just
it's
checking to see if
done.
anybody else had a similar question and maybe some other answer to fix the problem.
Yeah, I mean, here in the docs, they are very explicit about what they support and what they don't. Like they say, for instance, they don't understand the module system. So if you have two types with the same name in two different modules, they don't understand which one is which. Um,
Okay.
which I mean makes sense. They're just a tool that parses, I think, Rust code, and they're not like a full compiler, so they don't really understand deeply
Yeah.
like the code. They just see two things with the same name and they get confused. And a compiler would be able to understand which one is which, but they don't do that. So
Yeah.
yeah, they're very open in a way about the limitations. They say you can do this and you can't do that. So I was expecting, I
That's
don't know.
good. Maybe they would mention that. Yeah. If they,
Yeah.
yeah. I guess yeah, if we make an issue here, they'll probably just add it to their list of things they don't do.
Yeah, so the first thing they do is probably that because it's not easy at all
Yeah.
to implement.
Yeah. Well, I mean, yeah. I guess it's still, the tool still does quite a bit. So
Yeah. Oh, they also have these generating Swift bindings, which I did. It's the first time I noticed this.
yeah. Well, that'll come in handy because I think, you know, once I understand how Java works for this, I'll want to take a stab at Swift. I don't know Swift, but I think that's for my goals. I want to be able to support both Android and Swift.
Yeah.
So um, yeah, my impression was that it's probably going to be easier because it's a more C-like
Yeah.
language, but I guess we'll have to see.
I think you can even like call C functions directly. So if you have a C header, you can just use that directly. But it's probably not
Yeah,
like super polished. Like even in Rust, for example, you can call C code directly, but it's not super.
yeah,
It doesn't feel like native. So maybe we'll have to
yeah,
do something more to make it feel more Swift like style.
yeah,
But yeah, it should
yeah,
be easier because you don't have to You don't have to deal with like a JVM or anything. It's just
Right.
native
The
code.
basic raw, yeah, the raw types will probably be similar, like strings and
Yeah.
pointers and stuff like that.
Yeah, I think I'm gonna throw away all of this and find a different way.
Are you going to record this session too?
Yeah, it should be streaming actually, and then I just
Okay.
take the stream and yeah.
Ah,
It,
cool.
it says there's always one viewer, but I think it's fake. I don't know if there's really somebody viewing it.
Maybe
Every
that's
stream
the
I've
viewer
done.
that's doing the recording. That could be the
Yeah, could be.
recording
Yeah,
viewer.
this thing. I don't know. Yeah, I'm not really very like familiar with those stuff. I'm not. I've never like streamed games or anything. But I've seen a lot of my friends do it, so I'm just kind of taking inspiration from them.
Yeah.
It's also pretty late. I didn't notice it. Yeah, I'm just gonna try one thing quickly and then probably end it here.
Yeah. I'll just watch. I won't interrupt you.
Yeah. There was also another thing that I wanted to do, which I forgot. And I said this is easier and I'm gonna do it at the end because it's quicker, but I don't remember what that was. I don't know. Yeah, whatever.
It'll come to you tomorrow.
Yeah, I think so. Sooner or later, it's. Yeah. So I think without the traits, we're gonna have to be like more explicit um, in the way, like in this kind of tag attribute that we add, where we say generate the getters and setters. With the traits, it would have been basically able to understand if it's a complex type and it needs to generate the getters or the setters in a way, or if it's like a native type, like an integer or a string or like simpler types and generate them in another way. But without them, we're gonna have to be explicit, like say generate the getter like the simple version, or generate the getter the complex version. I think.
So on a field by field basis, basically,
Yeah.
it'll make that try. Yeah. I think
So
it
this
makes
is
sense too that, yeah, you would always have getter. I mean, if you put this annotation, you would always get getters and setters, whether or not that inner type is complex or not, or has complex items or not.
yeah. I mean, the only issue is that you have to like manually choose which one, and maybe I mean, if you pick the wrong one, it's just not gonna compile, so it's not a big deal. You can do it accidentally and just find out later. But yeah, it's a bit more painful, I think. Or maybe
Because if you don't, you're saying if you don't, the only situation where you wouldn't generate getters and setters in that case would, like you said, like those simple types, integers and characters, I guess.
It's not that you don't generate them; you generate it in a different way. So like basically here I'm wrapping the type with, like for instance in Python, I'm wrapping it in that py thing, and then when you call the getter, I return a clone reference to the same type. But for instance, for a U32, I would just return a copied. I don't need to wrap the U32 into an object and then clone the reference. I just copy the value itself and return it, and that's fine. So these are basically the easy, simple getters and setter are just this, are basically what you would expect from a getter or setter. And then the more complex ones, they do extra steps. They do like, what was it?
That's the pie, yeah.
Yeah, they do this kind of stuff, like they do clone ref and weird stuff. So the idea is that
the boxing and
yeah, so those are the ones we generate now. I would also like to generate those, but you will have to be explicit about which one you want to generate, which could be get trivial, or I don't know, get simple versus just get, or the other way around. So just get is the simple one, and then you have get wrapped for the complex type. I don't know, but you would have to manually like switch
I see.
between the two.
So you're saying you would have to do that on each field of your
Yeah,
complex type instance. You would just say, okay, I'm looking at it. I know it's a U32, so
yeah,
I'm going to call it get
yeah. It would
simple.
be like something like this.
Yeah.
So if you have a
Yeah. I mean,
U32,
yeah. I mean, it's a little extra work, but it seems still pretty reasonable.
yeah,
Just because, I mean, again, hopefully these structures don't change that often.
yeah. No, it should be mostly like a one-time thing. You just do it when we add something new to the library. You just do this. You wrap everything, and then once you're done, it shouldn't
Yeah.
change that much.
Yeah. Yeah. So that's why it's not. Yeah, especially if it simplifies your macros.
Yeah. So I think I'm gonna. Well, I have one thing in mind that I can use to simplify the C version a little bit. So I can store it as a box. I don't know if you remember that we had to do the custom destructor and everything.
Yeah.
Because I was storing a pointer, and so it was like my responsibility to free the memory pointed by the pointer. But instead, if I store it as a box, basically Rust will do it for us because it's not just a pointer. A box is like an object we own, and there's a way to get a pointer to the box without destroying it, which I wasn't aware the last time I did this. So that's why I did it the other way. But
So what's the life cycle of that box? Like, how does the Rust side know when it's out of scope?
well, it's like every like Rust object. So like for instance, if I have a variable inside a function that is a box, at the end of the function it will destroy it because it goes out of scope, unless I move it somewhere else. In this
Right.
case, it's a field of a structure. So when I drop the structure, it will drop every field. But the point is, here the type is a box of type. So box is like a known object. So Rust thinks that the structure has ownership over that memory. And so if you drop the structure, you also have to drop this field because it's owned by the structure. And before, instead, I had just a pointer, and a pointer is not something you own. Like, yeah, you own the pointer, but you don't own the memory pointed by that pointer. So Rust was correctly not freeing that memory because it was like, you're dropping a structure and there's this pointer, but I don't own that memory, so I'm not gonna drop it myself. And this is why we had to do it manually. But if instead I have a box is an owned type, so it will do it basically automatically.
But okay, that makes sense. Yeah, that seems good. But I guess maybe this is a different question, but when like I do a getter and I get a complex type, that complex type is going to be in a box, right? And then the C side of the program, for instance, is going to make method calls, are going to make potentially getters and setters on that boxed type. And then when does the Rust side know that the C side is done with it?
Well, there's kind of no way of knowing that. So this is, I mean, in Rust you can do it because you have lifetimes and everything, so the compiler can check. Here is just we have like an explicit descriptor that you call from C, and if you call that descriptor, I mean, it's up to you to make sure that you're not.
I see the C. Right. So the C side has to explicitly release that.
But the point
object
is
that it requested.
You have to explicitly destroy the whole structure, and then like you make one call, which is destroy the structure, and then the Rust compiler will destroy every field. But if the field is not a known type, Rust is not going to destroy it. So basically, without the box, we had to implement a custom destructor to like really make sure that we were freeing that memory. And instead, yeah, it's still an explicit call. The only point is it's different what Rust does, basically. So without the box, Rust doesn't free that memory, and with the box it does, but it's still an explicit
call
that you make from C.
Right. Yeah. At least for the top level owner of it, you just have to, the C side just releases that, and then the Rust, I guess basically the Rust memory management handles the rest of the releases or rest of the freeing.
Yeah, so the destructor is actually very simple. The destructor is usually a function, a method that takes self by value, and it doesn't do anything. So basically, at the end of the function, Rust will say, okay, I own this, so I need to destroy this. I need to free it. So yeah, this is like very simple, the destructor. So from C, you call this.
Yeah. And then Rust takes care of the rest from there.
Yeah.
Yeah.
And it's up to you to ensure that you're not keeping a reference around. But this is usual C stuff. So I mean, there's more responsibility in your hands. You have to make sure that you're not accidentally using something after you've freed it.
And I guess I think you showed me on the Python side, it already has a concept of like Python has a sort of, it knows when things need to be destroyed. So is that right?
Yeah, in Python, I don't really have to do anything. It's everything is done by PyO3, which is that thing that I use to generate the real like Python stuff.
So when the Python runtime basically is done with something, the PyTree ties into that to call your Rust destroy.
Yeah, I think I mean in the end you have C API. So this PyO3 thing is just a nice Rust kind of interface to the C Python API. So I mean in the end the C interpreter calls C functions, and then there's all this Rust extra stuff on top in a way. But in the end it's just C functions, and I think there's an explicit function to basically just destroy an object. I don't know, I've never really done it manually, but
yeah, I mean, it must have, because I'm sure the Python runtime, or actually with Python, it may never destroy stuff. I don't know.
I think it's kind of like garbage collected as well. I don't really know,
Yeah.
But yeah, you don't have to do it explicitly, so it's
yeah,
it's done automatically. I think.
Okay.
Yeah, those functions that starts with pi, I think those are those C functions.
It's got a reference, kind of a reference counter too.
Yeah. So these are the C APIs.
Okay. Yeah, so there's a deallocation function.
Yeah. And I don't know what that function is, but it's probably, again, one function that you define. Is it clear? No.
No, it says it just goes to 0. I think you just have to worry about incrementing and decrementing, and then, oh, I see, you have to give it a function.
And then you probably define a function that is the destroy what they call the allocation function, which is probably like a custom one. And I think what PyO3 does, it's probably going to be very similar to this, but they do it automatically. So they will define, for our type, they will define a deallocation function that then calls the Rust kind of destructor in a way. Yeah, I don't know. So this is the C reference manual. I don't know. I'm just curious now, but yeah, I'm pretty sure there's gonna be. Oh yeah, so it's a garbage. There's a garbage collector basically.
Okay.
Oh yeah, so I think this is where you define like the destructor, which is it's a function pointer. So you can basically like give it a custom callback to call when you want to destroy an object.
Yeah. So yeah, just for any structures that the BDK puts out, goes across this interface, we'll have the standard deallocation.
Yeah, I think in Java, we're going to have to do it manually because the JNI create is not really like compared to Pio3, Pio3 like wraps your type for you and does everything. And this is more of just like an interface to the JNI, but you still have to do everything. It's just easier to talk to the JNI, but you still have to do the talking yourself in a way.
I think on the Java side, you can put you can call some code when the garbage collector was going to collect that object. But I think it's going to be more manual, because then we'll have to use that to call a native interface on the JNI C code.
They have example project.
Yeah, it seems like the JNI code is, this JNI project is primarily helping with just kind of initiating requests and handling like strings, basically.
Yeah, they do strings very well, not much more than that.
Yeah.
I don't know, but yeah, I think, I don't know, in a way this is probably going to be closer to C, because you have to do more things manually, but also I think Java is a bit easier to work with compared to Python, because you don't have so many locks and everything. Like in Python, almost everything you want to do, you need to lock the global interpreter lock, so you can access those methods whenever you want. You need to get that lock first, and it's kind of a mess. And in Java, I don't think there is like a similar thing. So you should be more, you're probably more like free to do whatever you want. So I don't know, it's going to be kind of in between. Yeah. So we don't need to do this anymore, because we just we just replace our field with a new box, and it will free the old one, because we are replacing it, so the old one is not needed anymore, and it's gonna free it automatically. And again, before we were replacing the pointer, so the pointer was not owned, so it was not freeing the memory pointed by the pointer.
I see. So it's a box from raw was basically just a pointer.
So what I was doing before is we had like old pointer. So let's say we had old pointer, but this, if we delete this, if we drop this, it doesn't free the memory. So we were creating a box, which is from row, and with this we get an object that we own. So now if we drop the boxed thing, it will free the memory, because now we own that memory, basically. So this is why we were basically assigning it to a variable and then just ignoring it. So when the variable then is dropped, it was also freeing that memory. But with this, we don't need to do it anymore, because now we have an object that is already something that we own, and we replace it with a new one. And since the old one is not needed anymore, it's gonna get destroyed.
Yeah, that's nice. I guess it saves you from doing that unsafe. It's whatever unsafe stuff is happening now in the box, or is happening, it's not even unsafe at all, I guess, because you're just letting the normal normal Rust memory manager handle it.
Yeah, because the idea is that from row, the Rust compiler doesn't know what that pointer that you're giving to from row, where does it come from, what memory does it point to. So this is unsafe. But here we never create a box from a row pointer. We create a box at the beginning, and then we take pointers to that box, but we never destroy it and recreate it. So it's never unsafe.
Yeah, that's nice.
Yeah. So this should more or less compile. Let's see. So this is, so we change the type instead of a structure to be a box. Oh, and we should also define the mapping, which is, trivial, but we should define how to create a box of T starting from T, which is just create a box. But we still have to do it to be explicit.
So this mapping, this is a global mapping? like for all for both Rust or for Python and C?
Those are global, and then there are some language specific that are basically these. Those are behind the feature. So like, so this is specific to Python, but those are up here. Those are generic. Yeah, they're basically for both.
Okay, got it. Okay, that's a nice. That helps me with the organization a bit. So you have the ones that apply to both languages or any language, and then you have they get overridden by the language specific ones potentially.
Yeah. Okay. Okay, so this is because it's not mutable, I think. Okay, I don't really understand where this is coming from. So expected the row pointer from the start. I think it's probably this one here, but I was copying from this. So basically before I was using this, so I was using box into row and then from row, but this consumes the box. And this is the other way of doing it that I was not aware of. And you can just take a reference and then cast the reference to a pointer, which is like the star thing. So this is what I'm doing. I have
like the dereference, yeah.
Yeah. So I have a box, like I have like this, box, and then I do this, which I mean looks the same. Or maybe I need to use parentheses or something because maybe they have different priorities. I don't know. Like maybe different operators have different priorities.
Yeah.
No, I don't know. Maybe it's not even that place.
Structure box expected. I can't tell if that's a negative or a tilde, or what is that symbol before PTR?
I think it's like a star PTR, so it means like pointers like this, not a reference with the ampersand. I don't know what that's called. Yeah, the star pointer. So it wants a star pointer of something, and instead it gets a box. Maybe
so it's as if the box isn't getting
I think
wrapped.
it's the constructor. Okay, because yeah, I forgot to change. Yeah, so I think it's in the constructor because I'm changing. Before I was storing a pointer, and now I'm not storing. So yeah, it might be in the constructor because I didn't like update it or something. I don't know. Or maybe it's not. Oh, okay. But then maybe it's the mapping because I have the mapping. So I know how to map a reference. Where is it? Yeah, I think it might be. There's no mapping basically from what it needs to. So yeah, let me explain that a little bit better. So the constructor is this, and it has a reference to inner. Then I clone the reference and I get an inner that I own. And then I just use map from. And here I want to create a box from this. And I think maybe this is not implemented, but no, it should be. It's what I implemented before, right? So it should be this one. So I've implemented, yeah, because the error is the opposite one. So it's not saying I'm expecting a box and I'm getting a pointer. I think it says I'm expecting a pointer and I'm getting a box, which is weird. Or maybe the destructor. That, yeah, okay, so it's the destructor because we are still destroying, we are still implementing the custom destructor.
You were destroying your pointer instead of letting
Yeah,
your box expire.
so I'm doing like box from row, and this is expecting a pointer, but it's getting a box. So this is the error. Yeah, I just don't need to do this anymore because we don't have it.
Yeah.
Which is in expose struct. So all of this, yeah, go away. Yeah, and we can also remove that thing which I didn't really like anyway, which is I was returning like the list of methods that I was wrapping, but I don't know, it didn't really feel.
I see. So you don't have to do that anymore because you're not going to have to manually know what they are.
Yeah, I was only using it.
You're not going to have to iterate through them anymore.
Yeah, so I was only using it for the destructor, and then I don't really need to do this anymore.
Yeah.
Yeah. Okay, so this still works. I'm gonna try to run the example. Okay, that's fine.
All right.
So it works in C. So yeah, this is just the kind of refactoring. I mean, I just cleaned it up, the thing. Well, we need to check for the memory leaks.
You're refactoring that. You're going to do the memory check.
Oh. Yeah, I'm just to make sure, because now I don't have the custom destructor. I want to make sure that it still destroys everything.
Yeah.
So okay, so that's nice. Everything was freed. Okay, so still, yeah, so this is still good. Yeah, can commit this.
That's a neat command. I haven't seen that, staging hunks at a time.
Yeah, so it's git add -p, and you can say like yes or no for every, because I don't want to commit this. I don't know why, so I still have to kind of debug this, but I use the workspace. So when I run cargo format in the like root crate, it will also format the derive crate. But for some reason, if I leave this like that, when I build the library, it basically doesn't work. So for some reason, the when I try to link like the C executable, it doesn't link. It says that there are missing symbols, and I don't know. So yeah, it just for some reason I have to comment it out when I want to build. So I just like uncomment it for the cargo format, and then I recomment it. And so here I just I basically I wanted to commit everything except for cargo Tom.
Yeah, no, that's a nice trick.
Yeah. I don't know. I mean, not super. I mean, I don't want to spend too much time like explaining the stuff because probably nobody's gonna read them anyway. So
yeah, I think this is still the 0.0 version, so you're safe.
Yeah. I have to answer a few texts. Just a second, then I'm gonna.
Okay.
Go ahead.
Okay.
I'm going to sleep in a while. Bye-bye. Thanks.
Bye, Ricardo.
See you, Ricardo.
Okay, so I think I'm gonna try this thing quickly and then I'm gonna stop.
Okay.
So yeah, it was the get simple thing that I wanted to do. So I have a piece of code that basically defines like which option you can pass in here and how to parse those options. So I will have to add them, add the two like get simple and set simple to that. I'm gonna.
You've already implemented those two different things.
Yeah, so it's like in here. So these are the options. These are always available, and then there's subclass which is only available under Python because it's a Python specific thing. Yeah, basically if you use expose struct and then you say sub, I think it's like that. I should change this to remove the quotes. I just that I didn't know how to do it without quotes the first time when I did it. So the first time I did it with the quotes, but now I'm doing all the others without, I think. But yeah, the point is if you do this, you get a class that you can extend from Python. So this is pretty cool. You can have a Rust, so you can define a class in Rust, but then extend it from Python.
Oh my God.
Yeah, so this is again like Pyo3 magic. I don't really do, you just have to pass this subclass to Pyo3 and then it does everything.
Yeah.
And this is what I use basically to be able to implement, it's kind of on quotes, between quotes, but implement traits from Python. So basically I define a class with all the methods that just throw an exception and they are like not implemented. And then you can extend that class from Python and provide like a real implementation for every method. And then from Rust, when I call those methods, and again, it's complicated because you have to basically ask the Python interpreter to figure out which one to call. If you just call the Rust method, it will call always the Rust method, even if the class has been extended from Python. So instead you have to go through the Python interpreter and try to call a method from there. And the Python interpreter will figure out if basically if you want to call the base method or if there's a newer, like, I don't know, a version that overrides.
Overriding method kind of.
Yeah. So basically in practice, this is like if you want to implement a custom coin selection from Python, in Rust, I will have a structure that is a coin selection algorithm or whatever, with all the methods implemented on it that just throw an exception. And then you can override those methods from Python. And then when you call like a create transaction, you give me an object of that class, and I will try to call the method I want through the interpreter. And so if you've done everything right, I will end up basically calling your Python function, which is like Python code. So you don't need to do anything in Rust at all. You just write pure Python code.
That's going to be a fantastic little blog post someday.
Yeah, the only...
all the Python lovers are going to go crazy over that.
Yeah, there was like a stupid limitation somewhere. Where, not really limitation, basically to make it work, when you extend the class, you have to add like a couple of lines to set. I think you have to set a reference to self somewhere, because then I need it in order to basically ask the interpreter to call the right method. I don't know, it was like a weird thing, but yeah, it's just gonna be just copy paste these lines basically in the constructor of your extended class. You just have to set something to self, and then it's gonna work.
You know, there's a problem to all this that you're doing for Python, is now you're setting the bar really high for the other languages.
Yeah.
That's all right.
Yeah, I mean, in Java, you should be able to do that through interfaces. I mean, I have no idea
Yeah,
how this goes.
I think it probably could be. I mean, it would normally be done through an interface, so it can probably be done through interface. I'll have to think about it. Which language features? I mean, because you can have what are called abstract interfaces, which have unimplemented methods that you have to implement. So
yeah, that's basically what you. Yeah, so basically for every.
Take it back.
Sorry.
Yeah. No, I was gonna say, like, actually, I take it back. Interfaces are never implemented, but the abstract interfaces can have implementations, or like a default implementation, or a user-provided implementation. You know, like a subclass implementation.
Yeah, but I mean, I think in this case, we don't really. I mean, ideally, we would just do an interface, because basically a Rust trait is an interface. It's not really a class by itself that you extend. But I mean, in Python, you have to do it as a class, because Python doesn't have the concept of interfaces. I think I'm not sure about that, because I'm not really super familiar with Java.
I see. So if you're creating, I see what you're saying. So you would have like the Rust side has a trait for coin selection. You would just present that as a Rust interface that would get implemented on the Rust side. And then I guess it's going to get called back, though. Like the Rust side is going to call the Java side for that coin selection implementation.
Yeah, that's the problem. But I think it should be doable, I think, in a way.
Yeah,
basically.
JNI says they support it somehow.
Yeah.
I mean, there's a way to call back into the JVM to access objects.
Yeah, there was a call something method, I think.
Yeah, to the JNI environment, I think it was actually. Maybe it's here.
This one. Oh yeah, there's a call method and everything. So yeah, it's basically you have to go through this stuff.
As long as you know its name, I think you can do it. So, and the names follow that kind of, there's like a formula, like kind of a pattern.
Yeah.
So yeah, and I think we talked about before, you were gonna sort of prepend the module hierarchy into the kind of class path.
Oh yeah, you can do that. It's pretty easy, because you have basically all you need. So what was it?
Yeah.
So it's like the I think first is the package, basically. Then you have the class name, and then the method, I think. And you have like basically all you need, because you have the mod path, which is the package, the equivalent of the like every item of the package. You know the structure name and you know the method name, so it's so you have everything you need to to create that.
Reconstruct that. So that'll be a fun thing to try.
Okay, so what did I want to do? I guess
you were doing that native getters and
get simple. Yeah. So
I forget what you called it.
Yeah, so I think I'm gonna go with the simple one. So I don't know which one should be the default. So I'm just gonna do the default for the complex object and the simple for the simple types, because I think most of the time we're gonna be exposing those. But yeah, we can switch them later if you want.
That makes sense.
And the parsing is super easy, so it's like so this is kind of ugly because of that quotes thing. So this is like you get a parse string, you get the first item without removing it from the buffer. So you just look ahead is just basically look at the first item without
right. Oh,
and then you can
just a peek ahead, yeah.
Yeah. So this is like if the first item is a literal and it's a literal string, because it could be like a literal number, or if you have 5, that's a literal number. And then you try to parse the literal string and you take its value, and if the value is equal to opaque, and this is the way like you parse stuff with quotes, which kind of sucks. So this is much better without, without quotes, just a word like that is usually considered a path. A path is like a module path. So it's like items or identifiers separated by double colons. But in this case, I just ignore. So I always use, like, it's always a path of length 1. So what you do is like you try to parse that as a path, and then you try to, this get ident returns none, I think, if the path is longer than 1. And if it's 1, it returns the first item. So it's like, not dying.
And this code we're looking at, this is sort of macro code, right?
Yeah, so this is still,
macros.
yeah, procedural macro. Get ident. Yeah, so it's just one item, it returns that one, and it also shouldn't have any leading columns or anything. So all of those are paths that respect this, just a single item, no leading columns or anything. So yeah, so it's just, we try to parse it as a path, and then we try to get that first item. And if it's not one of the other ones we expect, we're gonna say, oh, we expected one of these. Otherwise, we just parse them.
Yeah.
Yeah. So yeah, I think I'm gonna change. I'm not changing it yet because I don't want to go around through the code and remove the quotes. But yeah, eventually we should do it.
Then it'll just become one of these match conditions, basically.
Yeah, it just become one of those. Okay, so it's. This is like the part where we parse those. So punctuated is a structure that comes from scene. It's basically, you can use it to parse stuff that are separated by a specific punctuation. And this is all generic. So punctuation can be whatever you want. In this case, we're using a comma. And the type can be whatever you want. In this case, we have expose, struct options. So we are trying to parse a punctuated of that, and you can use this. This is kind of a shortcut to get the comma token. So basically, this is a punctuated of those stuff separated by a comma, and then you have different parsers. Basically, the only difference is parse terminated is for 0 or more occurrences with optional trailing punctuation, and instead parse separated non-empty is 1 or more. So depending on what you want, you can either parse and also this doesn't accept trailing punctuation. So yeah, basically depending on what you need. In our case, you could also expose a structure with no options at all. So we use the terminated because we want the 0 or more. In other cases, if you always need at least one, you're gonna use the other one. Doesn't really matter. And this is the parser. And then we take the attribute. First, we iterate through the attributes to find the one that is exposed struct, because you could have more attributes on your structure. You could also have like a CFG something, I don't know, and we ignore those. So we look for the attribute that is exposed struct, or rather it's here, but it's the same thing. So this can have multiple attributes on it. So we need, even the doc, as I was telling you, is an attribute. So we need this specific attribute that is that starts with expose struct, and then we take that attribute and we can use parse args with, which is this one, which basically uses the parser we created before to parse everything that is contained between the braces. So this is like the name that we match, and then we parse everything with the punctuated of this parser. And then punctuated implements iterator of this. So basically you can iterate directly punctuated and it will kind of look like a vector of this type. So I iterate that and I create an hash set. So it's easier to make lookups. So if I want to see, do you have a getter or setter, I can just use contains instead of a vector.
Yeah.
So yeah, this is like the whole process to parse that.
It's funny. It's like, I mean, they must do something similar for all the built-in types. I mean, all the built-in attributes.
Yeah, I think some of those
code
are like kind of native. So I think they're like embedded in the compiler itself. But yeah, I mean, even a lot of like the bug that I fixed today was basically in something very similar. So in WASM bindgen, they have like different attributes that they use, and they use those stuff to parse them.
Right, you're both using that syn tool,
yeah.
Syn crate. Yeah.
Yeah, I think pretty much everybody uses that because it's very, very convenient compared to doing it manually, basically.
Yeah.
Actually, I was surprised that I think it's maintained by just one guy, basically, this whole library. I thought it was like a Rust or Mozilla thing, but instead it's like this guy doing almost all of it by itself, by himself. Yeah, it was. Yeah.
Contributors, maybe.
Yeah. Yeah, I like to look at those stuff, and he has like 2,000.
See how they do it. He's got most of it. Wow.
Yeah, I'm always like impressed by those people.
Yeah.
I think it should be probably like an else if, because if you have like the normal getter, you shouldn't also have the simple getter, I guess. You can't have both.
Yeah.
Yeah, makes sense. And the simple doesn't need to wrap the type. And then I think we're gonna add like an option to expose getter that is like is simple or something like that. No, I'm just gonna add it right now.
Yeah.
Is false.
I guess you could see that if then else thing as a big matching case potentially. I don't know, like, because there's a bunch of combinations. If you wanted to handle every combination, it would maybe there's some way you could do it that way.
I think. Let me check. I think
they
should be
a lot of combinations. You think the if else you can do it that way too? I guess.
Yeah, but there's no else in here, so I think it should be already covering all of them, because the idea is that if you have like a get normal, you can't also have a get simple, but you can have either no setter or a complex setter or a simple setter. So the only else is between get and get simple or set and set simple, but you can mix them up if you want.
So it would be valid to have a complicated setter, say, and a simple getter?
I mean, if it compiles, it's probably fine. I mean, most of the time, I think it will just not compile. The reason why you can't have both is because both methods would have the same name. So this is
Yeah, I see.
it's not going to work at all
So
because
right. From the point of view of this macro, this is the right. I mean, this is the minimum check you need to do. So I understand now that.
Yeah, no, I think I didn't realize. Yeah, I did not realize what you meant. That if you're like wrapping the type for the getter complex, you probably also want to use the setter complex. But yeah, so yeah, maybe we could check them with a match, as you said.
Yeah, but I think you're right that it wouldn't. I mean, if you had a non-complex type, that's probably all you need to really check is just to make sure in the complex one, in the simple one, that I don't know if there's any way to check that it's actually simple.
Yeah, I think we can start like this, and then if we really want, we can.
Yeah. No, that it's more just a convenience, I guess. It's not gonna.
Yeah.
It's probably gonna fail anyway if they try to do it with a complex. And it should be simple.
This is, I mean, more or less the same thing. We'll just clone and return the same type for the simple one. Yeah. I think it should, probably work. I don't know. Let's try with. Build variant. Okay, so this is the simple one, and it just returns the same type. This is, maybe this is not ideal. Maybe we should take the, not by reference.
You don't need a reference.
Yeah. Probably just because it's meant to be used for like simple types. So so this is the simple one, and the complex one does the mapping, and then you have a box and everything. So this is, and you have the pointer here. Let's see if it compiles. This makes sense. Forgot this in a constructor. Okay, it compiles. I'm gonna check the header file. We should also have, get value and set value, and these, they just take, like they return a U32 and they take a U32. This is
nice, very nice.
Yeah, I should do it for the Python as well. Yeah, it's gonna be quick.
Probably looks similar.
Yeah. Yeah, I think there's a lot of like, oh, actually, I think, I don't know, there's a lot of like duplicated code everywhere, which I don't like really like right now. But
You mean between the languages?
yeah, between the languages and also in the same language, like most of this is the same, but there are, I don't know, like little differences. Like if you need to wrap the type for this and not for this one. So I don't know. Maybe in the future we can clean that up a little bit, and like maybe we could have like a get bool.
I see.
Like,
rather than a whole separate.
Yeah, or maybe more explicit. Can be like is simple. I don't know. I'm just gonna try this very quickly. Yeah, so I think here we can use the match for this because this becomes like
right, because now you've got that Boolean.
Yeah. Oh no, it's not. Yeah, we can iterate on those. So we don't really need an hash set anymore if we do this. Probably even more. Oh no, so it was, yeah. I don't know, this looks a little bit better, I think. Less.
Yeah. Are you using wrap type? Where's wrap type?
This is like something that I use later. So wait, I will reset and then. So this is something that I use down here. So if wrap type is true, I will. It's basically the thing that, like for the complex type. Oh, yeah, this doesn't compile. Let me go back up here. So for the complex type, which was just inner, we wrapped it into a box of inner, and value instead remain the same type. So this is if you ask for either a complex setter or a complex getter, wrap type will be
either case
become true. Yeah.
Okay.
So yeah.
But yeah, that's common.
Yeah. I think problem is here. This doesn't exist. Where is this?
Set simple.
I think it's in here somewhere. Oh, I forgot to save. Yeah. Oh. Okay, makes sense. So I mean, for everything else, we're just gonna ignore. So we only care about those. There are potentially other attributes, but we don't care about them because they're used somewhere else. Wait, I think I have a. Why is this not? Oh, okay, so if you give me a. Okay, so we still get the simple one and the complex one. Probably remove, yeah, all of this. Yeah, there's also a lot of unused stuff everywhere.
Yeah.
I'm gonna clean that up sooner or later.
Yeah. So I love about Rust that it keeps track of all that for you.
Yeah. Okay, I think I can commit this.
Cool.
Are
you pushing this to your hello FFI too?
Yeah, so it's still on the work in progress branch.
Okay. I'm gonna check it out today too, just to go through my own copy of it.
Yeah. So I still have to. I haven't merged it yet because I need to sign the commits first because I don't have the keys on this. This is like a random new. It's like kind of a clean VM that I'm using just for this, and I haven't moved the GPG keys over, so I will need to sign them.
Yeah.
Separately, and then.
Anything I pull off, I'm just going to assume it's. I'm not going to make any commits to it, so it doesn't matter what you do to it.
Okay. Oh, I haven't done the Python version. I'll do it another time. I'm kind of tired right now, so.
Yeah, it's pretty late over there.
Yeah.
Yep.
Oh, and this is, did you know this? Git add -u.
No.
This is every updated file, which is, I mean, it's almost like doing like git add dot, for instance, but if you have untracked files, dot will add them, and u is only files that were already tracked and that you've updated. So it's a bit, I don't know, kind of safer to use.
Yeah, that's good to know.
Because
especially
if you use
this kind of stuff.
Yeah, if you do like git add dot, most of the time you end up committing stuff you didn't want to commit.
Yeah,
and then
you
have to
get your
go back
database committed or something.
Yeah, something like that. Yeah. Okay, should be. Yeah, so it's all in here if you want to try it out.
Yeah, I'm gonna take a look at it too.
I will also push, I think, my the thing I've done before that didn't work, but I want to keep it around anyway. Mm-hmm. Maybe in the future, I don't know.
Another branch somewhere to look at. Keep it.
Yeah. So wait. I think it was built on top of this.
That's your macro, your abbreviation for create branch.
Yeah, so these are actually not mine. So this came with the team.
This is from Z.
Yeah, ZSH.
The Z shell.
Yeah, I got used to. I mean, not all of them, but I think there's also gap, which is like git add -p. So the thing I was doing before. I don't know. There are like a lot of them.
Yeah, I use the same shell. I just haven't checked out I haven't really used any of their aliases yet.
Yeah, there are like really a lot of them. I don't use most of them, just a couple of them.
So No, that's, yeah, I should dig into those some more.
Um, yeah, not super. I don't know. I mean, I think I will remember.
Yeah.
Yeah. Okay. So this should be
All right, cool.
here as well. Yeah.
Okay, that's what you started with today.